Hello engineers, welcome to ASME BPVC Section-VIII Division-1 code training. From today onwards, we will start Module 2 lectures which cover all important mandatory and non-mandatory classes. So this is the first lecture which is mandatory appendix 44 cold stretching of austenitic stainless steels of pressure vessels. So let's begin this session guys. So what is cold stretching? What is cold stretching guys? So cold stretching is a technique which is used to enhance the mechanical properties of pressure vessels, particularly for stainless steel materials. This cold stretching process involves applying a high internal pressure to the vessel at a temperature below its recrystallization point, causing its plastic deformation. The primary goal of this cold stretching is to increase the yield strength and reduce the residual stresses in the material or a pressure vessel and making the pressure vessel more robust and reliable. So this is about cold stretching definition guys. So let's start cold stretching operation. So how generally industries will do cold stretching operation for pressure vessels. So if you are a cryogenic engineer, you must need to know about this cold stretching operations which is generally used in major pressure vessel industries. Let's understand what is cold stretching operation. So first, before starting the cold stretching process, so if you must need to ensure your pressure vessel is free from defect free or not. Then only you need to start the cold stretching operation. Otherwise, you need to do radiography tests, ultrasonic tests to check whether it is free from defects or not. And you need to ensure that the pressure vessel is clean or not. You need to clean before starting the cold stretching operation. Okay, so this is about first point, guys. Next, after completing all cleaning process and a defect testing process, so place the vessel in a controlled environment where pressure can be accurately monitored and adjusted. You need to keep your pressure vessel in one place where you can measure all the pressure so can be accurately and you need to monitor the pressure vessel accurately. So you need to place a pressure vessel in a separate place which is far from your normal manufacturing unit. Okay, and then you need to arrange water pipe and alarm detection system, pressure gauges, measuring tape. So these all these equipments you need to arrange it because you need to if you want to monitor properly these are all these equipments you needed. So and attach it to the pressure vessel for proper monitoring. Okay, so I will show you here. So this is your pressure vessel guys, this is your pressure vessel. So before starting the process you need to measure the circumferences because after cold stretching your vessel will be somewhat enhanced. Okay, so that's why you need to measure your circumference of the circumference of the pressure vessel so before starting the process. Okay, and you need to provide one vessel for water inlet and you need to provide another nozzle or opening for air flow out. Okay, this is how your pressure vessel look like before cold stretching process. Okay, so these are the some of the measuring devices you need to have before starting the cold stretching process. Okay, this is the pressure gauge, this is the tape which is used to measure the circumference of the pressure vessel. And next, so a measuring tape is attached circumferentially to the shell to measure any changes in the volume during and after the cold strengthening process. I hope you understand this process because I already explained it. Except water pipe, except this water inlet pipe, we need to close all other pipelines and provide only one vent line. So this is the vent opening, guys. So we need to provide this one vent opening and one water inlet opening uh, while during the cold stretching process. Okay, so all other pipelines, all other nodules will be closed. Okay, and next one, so fill the vessel with water. So we start filling the vessel with water and allow the vessel to sit with the vents open for at least 15 minutes to let any dissolved air to escape it. So at least we need to open this vent hole up to 15 minutes because while filling the water, if there are any air trapped in this area, it will be flow through this vent hole. Okay, so that's why this is the that's why we are providing the opening. Okay, after that we will close the vent line too. Okay, so only water inlet pipe will be open to increase the pressure, guys. So all except water inlet pipe, we will close all other ventings and seal off it. And next one, the pressure inside the vessel is gradually increased until it reaches the specified cold stretching pressure, which is denoted by PC. So after filling the water, we need to increase the pressure gradually. So up to cold stretching pressure. Generally, cold stretching pressure is typically between 1.5 times of P minimum. 1.5 means minimum and 1.6 means maximum. Okay, where P is our design pressure, guys. We need to maintain the pressure in between 1.5 times of P to 1.6 times of P. So after that, the cold stretching pressure must be maintained until the calculated strain rate drops to less than 0.1% per hour. So I will tell this point in few minutes with example, guys. And after that, so we increase the pressure, right? Gradually increase the pressure. So we need to maintain that pressure until the strain rate drops to 0.1% per hour, which ensures that the vessel has undergone adequate plastic deformation, which is enhanced its yield strength and made it suitable for high pressure applications. So by doing like this, by doing increasing the pressure gradually and maintaining until the strain rate drops to less than 0.1%, it will give uh, yield strength, more yield strength to your material, guys. It will give more toughness to your pressure vessel, so which is suitable for high pressure applications. So that's why we are doing the cold stretching process. So the main agenda of cold stretching process is to increase the its yield strength and the toughness is suitable for high pressure applications. So this is all about cold stretching operation. So I need to confirm you one more point. So the minimum holding time for your cold stretching pressure for vessels which is having diameter less than 79 inch shall be 30 minutes. So whatever the diameter is less than 79 inch, that shall be minimum. We need to maintain pressure up to 30 minutes. For above 79 inch dia, we need to maintain up to 1 hour. So this is the general timings which is followed by most of the industries, and also code given the same timings in the code book also. So I request you to please refer mandatory appendix 44 for clear understanding these points. So next one. So I already told you, right? We need to calculate the standards. So what is the meaning of this point? So I will let you clarify it. So before clarifying this point, if you are a viewer, please subscribe my channel and click on the bell icon. Okay, and hit the like button too, so it will boost my confidence. So and please share to your colleagues, friends, so it will helpful for my channel growth, and they will also benefited by listening these lectures. Okay, so let's calculate the strain rate. So first one, so we know strain rate means strain divided with respect to change in time. Okay, we are this is general engineering formulas. So strain is equal to change in length by original length. So you already know that in engineering we already studied about strain rate and strain. So how to calculate this strain rate? So let's see with example. So I already told to you, so before starting the cold stretching operation, we need to measure the circumference of the vessel, right? So before starting the cold stretching process, let's assume our circumference is 2000 mm. So after starting the cold stretching process, after 1 hour, it will be increased to 2020 mm. So after 2 hours, it increases to 2035, and after 3 hours, after 4 hours, it will keep on increasing. So this is example, guys. So let's calculate strain rate for this um, dimensions or values. So for first hour, so at the zero time, this is there is no change. It is our original dimension. Means original length is 2000, guys. Original length is 2000. So for first hour, what is the change? What is the change in length? So that is 2020 minus 2000. 20 mm is the change, right? So let's calculate strain for this. So strain is equal to change in length by original length. Change in length is 20 mm. Original length is 2000. So which is equal to 0.01. Okay, let's calculate strain rate for first hour. So strain rate is equal to 0.01 per 1, which is equal to, so this is time, guys. 1 means time. So for 1 hour only we are calculating, right? So that's why we are dividing with 1. So 0.01 or 1% per hour. So this is the meaning of this point. So we need to maintain a cold stretching pressure until our calculated strain rate drops to less than 0.1% per hour. So here we are getting 1% per hour, but we need to 0.1% per hour. Up to that, we need to maintain the cold stretching pressure, guys. So let's calculate for second hour also. So for second hour, what is the change in length? So 2035 to 2000. So which is 35 mm. So the difference is 35 mm. So what is the strain for this? 35 divided by 2000, which is equal to 0.0175. And what is the strain rate for this? So we are calculating for second hour, right? We are calculating for second hour. So we need to take difference between first hour and the second hour change in length. So which is 0.0175 minus 0.01 and divide by 1 hour. So we are calculating second hour, but the difference is 1 hour only, right? So we are talking about a change in time. So the change in time is nothing but here 2 minus 1, it is 1 hour. So which is equal to 0.75% per hour. Still we are not getting 0.1% per hour, right? So let's calculate for third hour also. unlike fourth hour. So if you're continuously calculating up to 4 hours, you will get 0.1% per hour. If not, you need to maintain cold stretching pressure for some more time. Okay, so this is the example for calculating the strain rate. So you would continue to monitor the strain rate until the pressure drops below 0.1% per hour. So if you look here, I already mentioned this point. You would continue to monitor the strain rate until it drops below 0.1% per hour, which is indicating that material has sufficient deformed and the rate of deformation has slowed down. So after getting 0.1% per hour, we need to slow down the process. So here you need to understand one important point, like at last half an hour, at last half an hour or 1 hour, whatever the time mentioned here, your strain rate must be 0.1 percentage, guys. Your strain rate must be 0.1% at least for this 30 minutes or 1 hour time. So this is the important point you need to consider while doing the cold stretching pressure. So this will increase toughness and yield strength of the material. So our major agenda is to increase toughness and yield strength of your material by doing this cold stretching process. So this is all about cold stretching operation. And next, so what are the essential criteria must be met if you want to perform cold stretching process? If you want to do cold stretching process, what are the key requirements you need to follow? What are the conditions? What are the general conditions or essential conditions you need to follow while doing the cold stretching process? So we will discuss it in next slide.